Bismillahirrahmanirrahim. Assalamu alaikum, class 8. So we are going to discuss the third part of our unit of physical and chemical reactions, that is type of chemical reactions. We are going to understanding the physical and chemical change, the formation of chemical reactions, the balancing of chemical equations, how to write the products and reactant side, what does the arrow represents, what is change in heat or change in energy, the category of endothermic and exothermic reactions. Now moving on to the total kind of reactions that takes place, and for how we can understand a chemical reaction in a better way. So there are almost 3 to 4 types of chemical reactions, and the third one, the displacement reaction, are further of 2 types, that is single displacement and double displacement, but the concept is the same. Number 1 is combination reactions. In combination, on the reactant side, if we have A chemical and a B chemical or an element, they combine and form one product. This is known as a combination reaction. Decomposition reaction. Decomposition means breakdown, and in a breakdown reaction, a compound is broken down into 2 parts. We can also say that it is the reverse of combination reaction. The reverse of combination reaction is the decomposition reaction. The third is displacement reaction. Displacement means change in its site, location, or from the place, a movement from the particular place of a substance. Single displacement means the change on the particular place of only one element, whereas double displacement means the change in place of 2 elements in a reaction. Let me explain it to you in a better way. Single displacement, in which A is an element and BC is an element. When a combination reaction of these two takes place, A will react with this compound to form AC, and the change in position of B will take place, and that will be another individual product on the product side. So this is known as a single displacement reaction. Whereas in double displacement, there are 2 reactants. One is AB and second is CD. So when the combination takes place, A will join itself with D and B will join itself with C in the product side, AD and CB. So this is how double displacement takes place. Now moving on to last but not the least, redox reactions. Redox reactions are also known as combustion reactions, a reaction in which oxygen is combined with an element. Whenever oxygen is combined with an element, combustion or burning takes place, and when that burning takes place, that release an amount of energy, release an amount of heat and that heat may be in the form of light energy, or that may make a reaction hotter, or may produce some light effect or glowing effect in the reaction. For an example, H2O, formation of H2O. We added H2 molecule in H2 hydrogen gas molecule and water is formed. So in the presence of oxygen, water is formed. So this is a combustion reaction or a redox reaction. Similarly, C3H8 combined with oxygen results in the formation of carbon dioxide and water. This is also a combustion reaction because of oxygen given to the reactant side. First, combination reaction. A reaction in detail we will discuss again. It occurs when two or more reactants combine to form one or more product. For an example, calcium oxide, that is lime. Calcium oxide mixed with water, it will combine to form CaOH. So this is calcium hydroxide. Calcium hydroxide, that is also known as, in some case, caustic soda. And this is carbon combined with oxygen that form carbon dioxide. So these are combination reactions when two molecules combine to form a single substance. And normally when combination reaction takes place, heat is released. So it is an exothermic reaction which involves the evolution of heat during a reaction, or that involve the release of heat. Combination reaction. Again, sodium added with chlorine formulate sodium chloride. Then we balanced it because we were having two atoms of chlorine, therefore we had to add 2 on the right hand side. When chlorine was balanced, 2 here and 2 here, then sodium was 2 as well due to by the addition of this 2. Then what we did to balance this equation, we added 2 on the left hand side as well. So the number of moles of atoms or on the left hand side is equal to the number of atoms of elements on the right hand side. Here you can see a visual reaction. 2 sodium atoms and 2 chlorine atoms reacted to form sodium chloride, and this is the general form of a combination reaction. A plus B is equal to AB. Two elements combine to form a compound. Decomposition reaction. These are the type of reaction in which the reactants are broken down. Decomposition means it is broken down or separated, and from complex to simpler products are received, or simpler products are formed. What happens is decomposition basically takes place when a solution or a material is heated. So we can say that it is also known as thermal decomposition. To break a compound, we need to heat that compound. For an example, we have to heat water, and what will happen when we will heat water? Hydrogen gas H2O will form H2, that is hydrogen gas, and O2, that is water. So what happens visually when we heat water in a beaker or in a saucepan? The water evaporates, and what happens is hydrogen gas evaporates and is released, and oxygen gas is released and becomes vapors and is flown up into the air. So So this is a decomposition reaction. Here you can see water, two water molecules, H2O. H2O, when broken down, will form hydrogen gas and water. And this is the general formula: AB, when heated, broken down into A plus B. Now the examples of decomposition reaction: hydrogen peroxide, when heated it transforms into hydrogen gas and water. This is formula of water. And when water is heated, or there's another process known as electrolysis. Electrolysis is a method in which electricity is passed through it, and what happens is electricity passing through is may cause a heating effect, and what happens, water breaks down into H2 and O2. Nitrogen triiodide, when heated, forms N2, that is nitrogen gas, and I2, that is iodine. Similarly, in a way like AB is equals to A plus B. This is a decomposition reaction. Displacement reaction, a reaction in which one or more elements displaces or changes location, and this kind of a solution is known as a displacement reaction. And when two or more elements are present in a compound, so in displacement reaction, the compound that is less reactive or is poorly bonded is most probably displaced from A or B side. The one whose reactivity is low, that element replaces the other element. So it is further divided into two categories: single displacement and double displacement reactions. For a better understanding, this is magnesium and this is copper sulfate. What happens is, when heated, magnesium is joined with sulfate, that forms MgSO4, and copper is intact, and this is the general formula. And in double displacement, calcium carbonate and hydrochloric acid, when heated, calcium combines with chlorine from here to here, and CO3 plus H forms carbonic acid. So calcium chloride and carbonic acid is formed. This is double displacement. The ones which were less reactive changed their positions and relocated themselves. So both are heating reactions, endothermic reactions. Another example of single displacement is lead chloride and potassium iodide. Potassium chloride is formed and lead iodide is formed, and it took place. Firstly, the ions and the valencies are mentioned, and in the chemical equation that is at the bottom, you can see that lead chloride, potassium iodide, potassium chloride, and lead iodide is formed. And in the upper chemical equation, their valencies are mentioned. These valencies are automatically present in the periodic table on the top of every element, in which group they form, how many electrons they have in their outermost shell, and is their outermost shell complete or incomplete. So the double displacement is taking place. This is a visual diagram in which potassium carbonate and barium chloride displaces themselves in a container when heated, and potassium chloride is formed in liquid whereas barium carbonate is formed in solid. The reactivity series, as I said, that those elements which are highly reactive do not displace themselves, but those which are less in their reactivity relocates themselves. So when I go on to this diagram that shows the top element most reactive, that is potassium, sodium, calcium, magnesium, aluminium, carbon. These are the most reactive elements, whereas as we go towards the bottom, these are the least reactive: gold, platinum, silver, copper, hydrogen, and the middle ones are neutral. Not neutral, but they show reactivity in some cases and they remain intact in some cases. So those which are stronger may hit the other element which are less reactive. For an example, you can see calcium is more stronger and is reactive, most reactive side, whereas aluminium is less reactive than calcium. So calcium will hit aluminium and does not let calcium displace, but it will allow aluminium to displace because aluminium is less reactive than magnesium. Now the combustion reactions. Combustion reactions happen in the presence of oxygen, in which energy is released in the form of light and heat. Water, when combined in the presence of hydrogen and oxygen, water is formed. And when CH3H8 is burned in the presence of oxygen, carbon dioxide or water is formed. This can also be said that these are redox reactions in which oxygen is involved. So this is the same thing, that when a substance gains oxygen during a reaction, it is said to be oxidized, and the oxygen is lost during the reaction, and then what happens is a change in oxygen, or oxidation reactions takes place. So this is known as oxidation reaction, one and the same thing. I hope you understood the different types of reactions that we will come across in our next unit. I will also discuss the detail of valencies, the shells, how many number of electrons, molecules or atoms, the concept of valencies, and how we develop a chemical formula of any substance present in the periodic table as well. And we will also solve the numericals as well. Thank you, class. Go over this unit and these topics. Thank you.